Welcome to Efiwe, excellence without stress.
Hi, dearest Efiwe. We are back again on this our journey. I applaud you, I credit you for your resilience for coming this far on this beautiful journey. Today, our topic is introductory electronics. We're going to talk about semiconductors. Talk about semiconductors. So briefly, let's really talk about what conductors, semiconductors, and insulators are. Substances that allow electricity to flow through them are called conductors. Examples are metals like copper, silver, and iron. I'm sure we've established this in our previous class. Substances that do not allow electricity to flow through them are called insulators. Examples are plastic materials, glass, wood, air, etc. Now we have certain materials that have an electric resistance between the high value of insulators and the low value of what conductors. In other words, they are semiconductors. Examples are the silicon, germanium. They are widely used in the electron industry. We can see them, see conductors. Conductors, they have electrons and they have valence band, and we can see the valence band is no band gap. This is the conduction gap, no band gap. Why the semiconductors, they have narrow band gap. They have narrow band gap. Why the insulators, they have what? Wide one, very wide gap, very wide gap, and that's the difference between them. Mode of conduction in semiconductors. The current is carried through semiconductors by two types of carriers. We have free electrons, which have the negative charges, and we have holes, which have the what? The positive charges. So this is it, hole and electrons. So we can see the negative here, we can see the positive charges here. So the current is carried through semiconductors by two types of carriers: free electrons, which have the negative charges, and holes, which have the positive charges. Note, if the semiconductor is not subjected to an electric field, the position of the hole moves at random from one point to what? Another. But when a battery is connected, when a battery is connected, the valence electrons are moved to one particular direction opposite the external field, while the holes drift in the what? Direction of the what? Of the field. So that is what this is talking about. In a pure semiconductor, there are equal numbers of electrons and holes. So we've established that equal numbers of what? Electrons, and that's why they're called a pure semiconductors. Don't forget, it is the movement of valence electrons that creates electron-hole pair in a semiconductor. Effect of temperature on semiconductor. The resistance of a semiconductor decreases with rise in temperature. Hence, conductivity increases with what? Temperature rise. I'm sure we already understand that. So the rise of a semiconductor, it decreases with what? The resistance of a semiconductor decreases with a rise in temperature. So types of semiconductor. Before we look at the types of semiconductor, we need to understand the concept of doping. What is doping? Doping is the addition of small quantity of an element to increase the characteristics of a semiconductor. So doping is the addition of an element to increase the characteristics of a semiconductor. That's what doping is. We basically have two types of semiconductors. We have the intrinsic semiconductors, and we have the what? Extrinsic semiconductors. And we are going to explain that. We have the intrinsic and the what? Extrinsic semiconductor. Don't worry, you're going to understand these types of conductor as we proceed. N-type semiconductors. This is produced by doping a semiconductor with group 5 elements like arsenic and antimony. So this is the type of conductor that is produced by doping a semiconductor with group 5 elements like arsenic and what? Antimony. So that is it. So there are more free electrons or negative charges in an N-type, just N, negative semiconductor, than there are holes. Holes are positive carriers. So there are more free electrons or negative charges in an N-type semiconductor than there are holes. Hence the name N-type, that is negative type semiconductors. While we have the P-type semiconductors, this is produced by doping a semiconductor with group 3. N-type were produced by doping it with group 5. P-type by what? Doping it with what? Group 3 elements like boron, and what? Indium. There are more holes because this is positive. Holes are the positive charge carriers. There are more holes than free electrons in this type of semiconductors. So these are just the differences. N-type, it is the donor type, that is the negative, it gives. While P-type is the acceptor type. Impurity atom is pentavalent, while impurity atom is what? Trivalent. Donor level lies close to the bottom of the conduction band. Acceptor level lies close to the top of the valence band. And these are the difference between N-type and P-type semiconductor. The p-n junction diode. A p-type semiconductor crystal joined to an n-type. We have the p-type semiconductors, we have the n-type. So when we now join p and n-type, so that's what we are trying to explain here. A p-type semiconductor crystal joined to an n-type semiconductor crystal to act as a single semiconductor crystal is called a p-n junction. This can function like a thermionic diode. The p-n junction diode ends can be used as a rectifier that can therefore change AC to DC voltage. It can be used as a rectifier and that can therefore change AC to DC voltage. Biasing, types of biasing. We have the forward biasing. Under this arrangement, the positive terminal, we can see the positive terminal is connected to the p-type of the battery. The positive terminal of the battery is connected to the p-type, while the negative terminal is connected to the n-type, and that is forward biasing. Under this arrangement, the positive terminal of the battery, this is the battery, is connected to the p-type semiconductor, and the negative terminal of the battery is connected to the n-type semiconductor. This arrangement has low resistance and allows much current to be passed. Resistance is refusal of current, but this one has low resistance and allows much current to be passed. Then the reverse biasing. So you can see that it's just going to be the difference. The other one, positive p-type semiconductor was connected to the p terminal of the battery, and n-type was connected to the negative terminal of the battery. But in this case, under this arrangement, the positive terminal of the battery, which is this place, is connected to the p-n-type semiconductor, while the negative terminal is connected to the p-type conductor. So this allows only small or no current to flow in the circuit. In forward biasing, recall that p-type has more holes. Yes, it has more holes. The positive terminal of the battery repels the numerous holes because positive charges they repel. The positive terminal of the battery repels the numerous holes or the positive charges across the junction. The negative terminal repels the electrons across the junction. You understand this because we are connecting the positive terminal of the battery to the positive p semiconductor, and opposite is the case. We are connecting the negative side of the semiconductor to the n-type semiconductor, and so they will repel each other. So the negative terminal repels the electron across the junction. This is what causes a massive current flow in the semiconductor and the circuit. While in reverse bias, when the negative terminal is connected, like times those they attract. It's connected to the p-type and the positive terminal to the n-type. Only a small current will flow to the external circuit because only the few electrons in p-type and few holes in n-type are repelled. Only just few. Most of the others are going to attract. They won't repel each other across the junction by the positive and negative terminal respectively. The p-n junction diode has several advantages over the thermionic diode. One, it is smaller and only needs a small PD to operate in a radio receiver. Only need a very small potential difference to operate in a radio receiver. It requires no time to warm up to produce electrons since they are already available in the semiconductors. It is cheaper to manufacture in large numbers. It is cheaper to manufacture. So we have the Zener diode. So Zener diode are used as voltage regulators or stabilizers in circuits. So when in our circuits, Zener diode are used as voltage regulators or stabilizers in the circuit. So look at now, these are transistors. Transistors consist of a triode. Why? Because it is called a triode because it contains 3 terminals. It has the base, the emitter, and the collector. The base, the emitter, and the collector. So because of these three terminals, we call them a triode. Those are the transistors. A triode. There are two types of transistors. We have the PNP transistors and we have the NPN transistors. What are the uses of transistors? They are used as current amplifiers, they are used as switch, power amplifier, in construction of logic gates, and used as voltage amplifier. Don't forget that we use group 5 elements to make the n-type semiconductor, and we use the group 3 elements for the p-type semiconductors. And that is all for today in this our class, in our introduction to electronics. I hope you had a great time. Thank you. See you in our next class.